Welcome to The Explainer. So, what does a car accelerating in traffic have in common with the average height of a wave? Well, the answer is one of the most powerful ideas in all of mathematics, calculus. And believe it or not, by the end of this, you're going to have a real gut feeling for how it works. So, our journey into calculus starts with a question that seems pretty simple at first, but you'll see it quickly uncovers a much deeper puzzle. Just imagine you're driving in heavy traffic. You're speeding up, you're slowing down, you hit a red light. Your speed is all over the place. There's no single constant speed for your trip. So how in the world are you supposed to calculate the total distance you've traveled? I mean, if your speed were constant, this would be a piece of cake. It's that formula we all learned back in school, distance equals speed times time. Simple. But the real world, as you can see from that graph on the right, it isn't a nice flat line. Nope, it's a messy, bumpy curve of speeding up and slowing down. And that simple formula, it just completely falls apart. But here's the thing. The solution to this is incredibly elegant. And it all comes down to just looking at the problem in a new way. Instead of trying to swallow the whole journey in one bite, we're going to break it down into tiny pieces. So here's the crucial idea. If you zoom in on a really small moment in time, like a split second, the car's speed is almost constant. It barely has time to change. So for that tiny little slice of time, we can use our simple formula. That tiny bit of distance is just that moment's speed multiplied by that tiny bit of time. And then we just do that for every single moment of the trip and add all those time distances up. And this is a great way to picture it on a graph. If we plot speed over time, each one of those tiny moments becomes a skinny little rectangle. You see? The height is the speed, and the width is that tiny slice of time. And the area of that rectangle, height times width, well, that's the distance traveled in that one tiny moment. So if we want the total distance, what do? It's pretty clear, right? We just add up the areas of all those thousands upon thousands of tiny rectangles. And just like that, the total distance you traveled is simply the total area living under your speed graph. Now, this whole powerful process of breaking a problem into infinite little pieces and then summing them back up, it has a name. It's called integration. And that's really all it is at its heart. It's just a formal way of adding up a whole bunch of very small things to find the total.